হ্যালো হ্যালো অভিজিৎ স্যার, হ্যালো হ্যালো অভিজিৎ স্যার, শোনা যাচ্ছে?
হ্যাঁ, শোনা যাচ্ছে গো।
হ্যাঁ, শুরু করে দেবো। স্যার তো বোধহয় নেই, মিউটেড আছে।
হ্যালো হ্যালো
হ্যালো স্যার, শুরু করে দেবো তাহলে?
আমরা শুরু করে দিই নাকি?
আচ্ছা আচ্ছা, সৌনক প্লিজ স্টার্ট দেন।
Yes, ma'am. Good morning, everyone. I welcome every one of you to today's workshop organized by the Department of Mechanical Engineering in association with IIC MCKVI on the topic Exploring Opportunities in 3D Printing. Now, I would like to call upon Dr. Abhijit Dutta, Assistant Professor of Department of Mechanical Engineering, to share with us his views on today's topic. Sir.
Okay, thank you, Sonak. So I am Abhijit Dutta presenting a topic on opportunities in 3D printing, upcoming technology. So wait a minute. Is it visible?
Yes, visible.
Okay. So first of all, the 3D printing technology is a process of is a type of manufacturing technology. So manufacturing means we have to produce something as per our sellable product. So first, going back into the first industrial revolution, with the introduction of steam engine by the James Watt in late 18th century, the textile industries are initially mechanized with the help of steam engine operation. And that was the first industrial revolution at that time. And before that, it was all our manually driven textile industries or anything was the manually driven. The second industrial revolution was introduced by the Ford company, Henry Ford, introduced assembly line production to meet the high demand of their cars. And here, you can see, to meet the demand, the car is continuously producing with the help of assembly line, or the mass production has been taken off. The third industrial revolution was first introduced in the 19th century with the introduction to the computer and the information systems. And if you see an example of the automation, this is the system which in the third industrial revolution we introduced the automation. So in the car industry, there is a word called marriage. Marriage means to put the engine into the chassis. So this process is known as marriage. So in the Porsche, you will see the marriage takes place in a plant where the engine is producing in a different plant and the chassis is producing in another plant. And every model, like if you are consider a sedan, a hatchback, a SUV, all are producing in the same assembly line. And the different models have the different engines. And those engines are producing in another plant. At a particular moment, the engine and the chassis come into the same place with the help of the automation. And that automation is only possible with the introduction to the computer as well as the information system, right? So this was the third industrial revolution, and this automation also helps to minimize the manpower. At the same time, it will increase the accuracy of the production. Now we are in the fourth industrial revolution. The main driving force of this fourth industrial revolution is the customization. So customization is very important as per our need. Whatever the thing may be, from safety pin to the aircraft, everything is customized nowadays. We want to use those things that will particularly or specifically suits our character, that will characterize ourselves. Like for an example, if we consider a watch which we are wearing nowadays, we always want that should be a unique. At the same time, the clothes that what we are wearing today, we always want it will fit to our as per our body size, as well as it will match our character. At the same time, the design, another thing, we don't want uh, anybody to the same type of thing wearing. So everything is customized and everything should be unique. Nowadays, you can also observe that the cars, bikes, everything are produced for a particular limited numbers. Like if we consider a Aprilia bike in RSB4, that can be only produced 150 pieces all over the world. At the same time, the MB Agusta produces its bike named the name is, I can't remember right now. It is the Veloce that is also in 100 pieces along the world. So these are the type of customization. That means whatever you want, that should be unique and it should be less in number and should not be you can see everywhere. That is also valid for a medicinal or the medicine industry. A medicine, like any drug which is been prescribed by the doctor for a particular patient, the quantity of that drug should be customized. For an example, if you consider pantoprazole, which is very widely used for the anti-acidic or proton pump inhibitors, it is available in the market in the 20 milligram and 40 milligram. If somebody is required 25 milligrams, so how to produce that 25 milligrams? Because it is not available in the market right now. So these are the things that that is why the fourth industrial revolution has come up. Here it is the both way connectivity between, you can see in the figure, that is the big data, robotic applications, Internet of Things, simulations, 3D modeling, cloud computing, and these augmented reality. So these all things are very common in nowadays. You can see everywhere, and almost every paper, newspaper, and every day, these are the topics that have been covering by the reporters. Now, the rapid prototyping is the first model or the first thing that has been produced from the concept to the reality. That is called the rapid prototyping. So rapid prototyping is an important aspect of 3D printing. The first model that is being produced from someone's thinking to the product, that is called the rapid prototyping. For an example, if we consider Super Meteor bike, which has been introduced in a very recent 2 to 5 days or perhaps 1 week earlier, in the EICMA 222 2022. The Super Meteor is a two-wheeler that has been introduced by the Royal Enfield in around 3 years prior to before the lockdown, right? So 2 years or 2 to 3 years prior, the Super Meteor has been launched, and it has been spied by the camera and we have observed this, how it will look like. And the thing is, the prototyping means you have to produce something and then review, redefine, correction, all the thing has been done, then built again. So in the meantime, that means within these 3 years of time, 3 years of time span, we have continuously, the Royal Enfield continuously redefined, tested, and corrected their faults, and then the final production has been carried out in this year. So this is the rapid prototyping, and these are the roadmaps where if someone have the concept, the concept means the idea, the abstract idea that comes into the mind, then you have to design it with the help of different softwares like CAD, CAM, CATIA, everything. Then the processing means to analyze how to find the material, the distributors, the where to sell. These all things are the processing, pre-processing, and then the final prototyping has been produced with the help of 3D model, 3D printer. This is the final product, prototyping. Now regarding the manufacturing system, so there are 3 distinct type of manufacturing system: formative, subtractive, and additive. Formative manufacturing system, what we do, the molten metal is poured into a particular cavity as per our desired shape, and we allow it to solidify. And after some time, when it solidifies, it will take its shape which is required. In the subtractive, for an example, the injection molding is a very good example of formative manufacturing system. In the ornaments industry, the formative manufacturing processes are widely used. Now, the subtractive manufacturing system, we have a lump of material, then we have to subtract it to get our desired shape, as you can see in the figure, with the help of different cutting tools, carpentry, any turning, drilling, milling, shewing, gear cutting, thread cutting. These all are belongs to the subtractive manufacturing systems. Now comes into the additive manufacturing system. This is the layer by layer deposition takes place, and finally we will get the desired shape, as you can see in the figure. So 3D printing is a kind of additive manufacturing process that now we will discuss. Now here you can see a CAD model. CAD means a 3D computerized design model that is sent into the 3D printer, and the layer by layer deposited to build the height. You can see in the figure how the additive manufacturing or the 3D printing takes place in this figure. Now the difference between 2D printer and the 3D printer. The basic analogy between the 2D printer and the 3D printer are the same. So in the 2D printer, you can see the normal computer printer. So we have a nozzle which is moving in the left to right. If we see from the front, so left to right, if we designate it as a x-axis, the paper that is coming out in the front and back, that movement, if we consider as a y-axis, so this is a 2-dimensional printing technology. On the other hand, in a 3D printer, instead of ink cartridges, we have the material, the plastic material, thermoplastic material that is fed into the 3D printer, and the nozzle moves X and Y, left to right, front to back, in this direction. At the same time, the bed where the printing takes place, that is moves from Z axis, that means up and down. So this is how we can create a 3D printing. So I hope it is very clear to us. The 2D printing analogy is applied in the 3D printing technology and how the product has been developed. This is the working steps where a 3D CAD model, which is designed in a particular SolidWorks, CATIA, AutoCAD software, that is .stl file format, is sent to a slicing software. Slicing means here 3D model is converted into a two-dimensional model. Then two-dimensional model, layer by layer, it is sliced. You can see in the figure, and creates a machine compatible codes, which is known as G code file format, and fed into the 3D printer. And the machine only understand the G code, and as per the G code, they print the product gradually, and final object is produced. You can see here. Now today we will discuss only four different or the most commonly used 3D printing technology. The first one is fuse deposition modeling. Stereolithography, DLP, is the digital light processing, and the selective laser sintering. Among these four, 2 and 3, stereolithography and the digital light processing are very close to each other. The only difference is in the stereolithography, we use UV rays, ultraviolet rays. In the digital light processing, we can use any light source. Now moving on to the next one, the fuse deposition modeling. So as far as the name suggests, fuse deposition modeling, so it is very clear that the material which is used in this type of 3D printing technology, it is melt and then it is deposited as per our G code. So here the material you can see that is in a rotor, which is called the filament spool. Filament means this is a thermoplastic material. All are given into the names like PLA, ABS, nylon, TPU, ASA, PEI. These are the most commonly used FDM materials, and these all are thermoplastics. It is sent to the extruder and then nozzle. Here the heating takes place, then the molten material deposited on the bed. The nozzle is heated, the material is deposited on the bed. As per our design, the bed is moved in up and down direction. You can see in the left hand side, X, Y, Z direction is given. So bed moves in up and down direction. The gradually build take place. So layer one by one layer deposited over it, and then gradually the height of the object will be gained. So this is the process of fuse deposition modeling. So fuse deposition modeling, we use a thermoplastic, and the material is known as filament here. Filament means this is the material which is used. The next one, you can see the another schematic diagram of fuse deposition modeling. In the previous one, it is only using one material, one nozzle. So here it is two nozzle. We can use two material at the simultaneously. So all are obviously thermoplastic. You can see the movement of the nozzle in the X, Y direction, and the bed in the Z direction. Now, fuse deposition modeling, infill plays an important role. Infill means it provides the mechanical strength of the model. Now, depending upon the strength we require, the infill takes place. This is say 25%, 75%, and this is around 90% infill is there. Here, we are using square infill instead of this honeycomb structure and other different type of meshing, triangular infill, all are possible to give the good strength of the printing product. Next is stereolithography. Stereolithography, you can see the printing takes place under the bed. Previous one, you can see the printing takes place above the bed. Here, the printing takes place under the bed. This is a resin tank, and this is a UV UV torch that is focused on the resin. And as per our diagram or as per the design, the UV rays solidifies the resin, which is used in general polymer resin, of course, photopolymer resin. The name is SOMOS 14120. So that is solidifies as per our diagram, and finally the product is developed. You can see in the figure here the product development takes place within the resin tank, and I will see you some video on the stereolithography later on this description. The next one is digital light processing. As we have mentioned, the stereolithography and digital light processing are very close to each other. Instead of UV light, you can see it is the UV laser source. Here we can use any light source, and the resin tank is here. And again, the other mechanism are almost same. The formation of a particular product or printing takes place under the bed within the resin tank. This is the photopolymer. The polymer which is used in here is bit different with the previous one, SLA. And then the solidifies as per the laser light comes in the polymer, photopolymer, and the final product develops under the bed. So this is the digital light processing. The next one is the selective laser sintering. So selective laser sintering is basically used. It is a powder-like material. Again, this is a plastic material. So here it is a bed moves in up and down direction. Here a laser falls on the powder, and then it is solidifies. And like this way, the selective laser sintering works. I will show you a video on the selective laser sintering particularly. These two, the stereolithography and the selective laser sintering, are very important. The stereolithography and the SLS mostly used in the biomedical applications. These two, selective stereolithography and digital light processing, used in biomedical applications, whereas the selective laser sintering mostly used in the automobile industry. So next is the comparison among these 4 different types of 3D printing processes. These are the applications where the SLA, FDM, SLS, and DLP are the predominating. The accuracy, you can see the SLA and DLP are very accurate. The fuse deposition modeling are reliable and accurate, but SLS is not accurate. This accuracy is depends on different parameters that will be discussed later on. These are the materials. You can see all of them are mostly thermoplastic materials, though there are a few metal used in the selective laser sintering that is not mentioned right now. The finishing option, the excellent finish quality can be obtained with the help of stereolithography. That is why it is used in biomedical applications. The post-processing requirement. The post-processing requirements is the removing of the supporting structures. That is very much important. So that is surface finish at the post-processing requirements. So that is not required if you apply SLA and SLS, sorry, selective laser sintering. So now I would like to show you a few defects. So most of the defects is due to the fuse deposition modeling, and the key feature for these defects is the temperature, feeding rate, and the nozzle position are the main cause of these different type of 3D printing defects. So you can see somewhere under extrusion, that means if the material deposition is slow, so what will happen? Over extrusion, what will happen? This is the overheating case. You can see here. Stringing or oozing is another problem. And the layer shifting, that is also due to the position of the nozzle. Now I will show you a small video which will give you a good idea about the different processes. So this is the dental application of stereolithography. You please see this.
The Form 3B provides dental practices with reliable, affordable, chair-side 3D printing of biocompatible products at a cost you can afford. From surgical guides to splints, models, dentures, and even aligners for simple cases, the Form 3B can streamline and modernize your digital dentistry workflow, leading to better and faster clinical outcomes.
We spent a lot of time thinking about how we can make working with the Form 3B intuitive and seamless, whether you're a dentist, orthodontist, lab manager, or technician.
Our Form software integrates with existing imaging and CAD solutions and helps you prepare your part for printing and initiate the print job wirelessly. The Form 3B's mess-free, easy-to-use resin cartridge system, compatible with existing Form 2 resin cartridges, and the easily replaceable resin tank and build plate, make changing materials and getting the printer ready to print a simple 3-step process. The Form 3B produces parts with unmatched surface quality and clarity. We fine-tuned our state-of-the-art new low-force stereolithography technology for optimal performance with biocompatible and other dental-specific materials. Smart sensors throughout the printer monitor print progress in real time and keep you informed and ready to promptly address potential issues. When the part is done printing, you can take it to the finishing station, where it will be washed in IPA, post-cured, and prepared for use. Light touch supports make removing support structures easy and leaves virtually no marks on the part's surface.
The Form Wash and Form Cure integrate perfectly with the Form 3B and make washing and curing printed parts a no-brainer.
Optimized settings for each material take the guesswork out of post-processing, leading to a streamlined end-to-end solution. From there, the part is ready for sterilization and use.
And whether you're new to dental 3D printing or a CAD/CAM guru, the Formlabs dental team is here to help.
Our new dental service plan includes personalized onboarding training, proactive check-ins, and the best phone support in the industry. Formlabs dental product development is backed by an industry-leading engineering team, a state-of-the-art facility for biocompatible materials development, and a team of dental industry experts. And with our years of experience as the leaders in desktop digital fabrication for dental practices all over the world, you can trust that Formlabs hardware, software, and materials are tried and tested from start to finish to deliver the best clinical outcomes.
So we have seen the stereolithography process in the biomedical sector. Next, I will show you the selective laser sintering.
Direct metal laser sintering, also known as DMLS, is an additive manufacturing technology that creates metal parts directly from 3D CAD data without the need for tooling. DMLS utilizes a variety of metal and alloy materials, such as stainless steel, cobalt chrome, and Inconel, to create strong, durable parts and prototypes. DMLS is an excellent choice for functional metal prototypes, high-temperature applications, and end-use parts. The DMLS process begins in the same fashion as other layer additive manufacturing technologies. A program takes 3D CAD data and mathematically slices it into 2D cross-sections. Each of these sections will act as a blueprint, telling the DMLS machine exactly where to sinter the metal material. The data is then transferred to the DMLS equipment. A recoater assembly pushes powdered metal material from the powder supply to create a uniform layer over the base plate. A laser then draws a 2D cross-section on the surface of the build material, heating and fusing the material. Once a single layer is complete, the base plate is lowered just enough to make room for the next layer. More material is raised from the cartridge and recoated evenly upon the previously sintered layer. The DMLS machine continues to sinter layer upon layer, building from the bottom up. As the part is built, support structures are added to give supplemental strength, define features, and overhanging surfaces. The completed part is then removed from the base plate and treated with an age-hardening heat process to further harden the part. Any support structures are also removed at this time. With numerous surface treatment and hand polishing options available from service providers, DMLS parts can be used in highly cosmetic applications. Typical uses for DMLS include tools and manufacturing aids, small integrated structures, dental components, surgical implants, and aerospace parts.
So we have just observed the two different types of 3D printing process. The conventional process is, of course, fused deposition modeling. And these two are the stereolithography and the selective laser sintering. How it works, we have observed. The next is the application in the different sectors. Because the day by day, the customizations are increasing. We want specific as per our requirement. You can see that the industry, as per the 3D printing technology, is divided into different sectors, and how they are, what percentage they are using with the compared within the conventional manufacturing systems. That is, pie chart is given here. The next one is the upcoming. What is the future of this 3D printing technology? The future is the printing of the different buildings. So you can see the different buildings nowadays that is 3D printed. It will help to save the material, because 3D printing, the fundamental objective is to save the material, and at the same time, the time requirement should be minimized. And that has been carried out with the help of these type of building 3D printers, that is build the concrete, different type of concrete. You can see in the lower, in the second figure, sorry, in this figure. And this is a very exclusive design of this building that cannot be done with the normal human effort. So this is done through a 3D printing technology. The next one is pharmaceutical. That is very important. The pharmaceutical, as I have mentioned earlier, that is the requirement of a particular drug is very, very important. Now, the AI-based diagnostic system is developing, as we are all aware. Google is doing that. So AI-based drug selective or drug recommendation system is very accurate. It will help to detect a particular disease, and it will at the same time it will help to recommend a particular drug with particular amount, and that particular drug can be produced with the help of the 3D printing pharmaceutical or the pill printing technology. This is called the pill printing technology. You can see the pill or a particular drug is printing with the help of this nozzle that is widely used in nowadays. The tablets and other thing that has been printed with the help of this 3D printer. You can see in the bottommost figure, that is the infill. In the previously, if we use infill in a mechanical structure, that will give the strength. Here, infill plays a vital role. It will help to modulate the drug doses. So if somebody required a lower doses of drug, in the figure, and the medicine or the drug is available in the type of this filament. The figure A shows the drug filament is the infill tablet, and C is the 100% infill, a particular tablet or the pill. That is also a very growing sector in pharmaceutical industry. Now the food technology, the 3D printing is also very, very important in the food technology. So we are very, very judiciously select about our birthday or the celebration cake, that the base will be this material, toppings will be this material, and the taste will be this material. Design of a cake, we are very much aware about the design of a cake or the pastry. That can be also done with the help of this type of food 3D printer. You can see here. So the food 3D printer is upcoming technology that is widely used nowadays in the baking industry. You can see here different type of material of different nutritional value, that you can see the protein content, calcium content, and the nozzle size. Depending on the nozzle size, the design has been done. And finally, the post processing is the baking. Baking has been carried out with the help of OTG or something like that. The baking takes place. So these are the way we can reduce the time. At the same time, as per our customization can be achieved from the design point of view. So these are the upcoming future of the 3D printing technology. So here is beyond this, what we have discussed, the food is one of them. So that the future application is the food. The scientist of the NASA is developing 3D printing food as well, that can be served in the space station. The bioprinting technology process, that means nowadays, if implant or the transplantation takes place with the help of another donor, someday it will come that the donor does not require. We will simply print the organ as per the genetic code or other thing is concerned. So it will print the required organs in the printer. Then the prototyping already has been discussed. So prototyping already it is carried out. It has been carried out from the very recent past. So prototyping has been carried out, and in the near future, it will more widely used in the researchers and the business industries, manufacturing technologies. So we will simply print our required parts and the robots. And these are the future application. And obviously, this is a very growing industry in this section. So that's all. This is our 3D printing in our college facilities. These are the fuse deposition modeling machines, FDM, the technology. There we have two machines, 300, one smaller and the larger one, 300 by 300 and 500 by 500. We have a 3D scanner and the system for the CAD and other design. And thank you, that's all. If you have any questions, please.
Sir, I have a question.
Yes, please. Yes, please.
Sir, you have started with the additive manufacturing. So I have that doubt that whenever we are using additive manufacturing, we are using certain metal granules, huh? Metal
Yes.
powder. Okay. So
Hmm.
can we use the granules directly just by granulating the metal, or there is some other procedure for producing that powder specially?
No, these all are nowadays which is available in the market. Those all are sintering material, right?
Okay.
And most of them are the thermoplastics.
Okay.
You know, the sintering material is the deposition or the solidifying of the material with the help of heat and pressure.
Okay.
Without going into the point, right?
Okay.
So
Okay.
obviously there is some limitation of materials. So most of them are the thermoplastics. Of course, few special iron-based material are now developing, and that is coming up.
Okay. Thank you, sir. Thank you.
Okay. Shaunak?
Yes. Thank you so much, sir, for sharing so much knowledge in this new area, which is so much upcoming and exciting. Thank you so much for that. And thank you everyone for joining this session.
Thank you.
Dear ma'am. Ma'am is, I think.
Yes, Shona.
Yes, ma'am. Then should we conclude now?
Yes, you conclude. Kunal, Kunal?